one of the lessons that I think statistics teaches us is that there are averages, and then there are us. There is us, right? So we can say a lot about average, but you are not average. Neither is the group of 4 or 5 or 6 people that you're sitting with right now. You're not average, necessarily. And yet, averages do tell us something important that can give us some information about us, even though we don't always fit into that category. So what I have up here is information from the Bridgewater State University fact book. When you first arrived as incoming freshmen, they asked you a bunch of sort of opinion-related questions and tabulated the results. These are the results from a couple of years ago, fall of 12. But for example, one of the things that it found was that the percentage of BSU freshmen who say that same-sex couples should have the right to legal marital status was 90%. Compared to, on the national average, freshmen across the country at institutions similar to ours, it was about 75% of freshmen at those institutions agreed with this statement. So this is a whole list of different political and public opinion statements that BSU freshmen responded to and compared to the national average. The rows that are highlighted here are where BSU freshmen significantly were different than the national average. So we might say that a significantly higher proportion of freshmen here at BSU agree with the statement that same-sex couples should have the right to legal marital status compared to the national average. And then also significantly smaller proportion of BSU freshmen agree that students from disadvantaged social backgrounds should be given preferential treatment in college admissions compared to the national average. So these are two places where the opinions of BSU freshmen are not equivalent to the opinions, are probably not equivalent to the opinions of freshmen at institutions like BSU across the rest of the country. So what I'd like for you to do with your team is to, first of all, choose one of these rows. So pick one of these political statements, any one that you'd like, and start by taking a secret ballot poll, just within the membership of your group. Find out how many of your group members agree with the statement that's up here. And because some of these are controversial, if you wish for that to be a secret ballot so that nobody knows who says what, feel free to figure that out. The second question, then, is suppose for a moment that your group were made of average BSU freshmen. Then how many of your group members would you expect to have agreed with the statement that you chose? So that's an expected value question. And thirdly, if your group were made up of average BSU freshmen, how likely would it be to get the same result as you found in your groups? So let me just take a hypothetical example. Let's suppose that my group chooses this statement here, the death penalty should be abolished. Okay. And let's say that I'm in a group of, I don't know, let's say I'm in a group of 10 people. And suppose that I take a poll inside my group, and I find out that 4 agree out of 10, just to pick a number for a moment. Well, based on the size of my group and the proportion of BSU freshmen that agree with this statement, how many people would you expect in my group to agree with the statement the death penalty should be abolished? Why 3?
Oh, it's like the 30%.
Yeah, it's the 10 people in my group multiplied by the 32.3%. Right? This is an application of the expected value formula for binomial probability. Right? This is E of x is equal to n, the number of trials, multiplied by p, the probability of success on each trial. So we're going to model this as binomial because we have, in principle, a random selection of n people coming into our group, random average BSU freshmen. And each one of those random freshmen has a 32.3% chance of agreeing with this statement. Right? And so we would expect, out of the 10 in my group, that 32% of them would agree. So the expected value would be 10 times 32.3%. Really, we would probably say 3.23, even though we can't have 0.23% of a person agree with this statement. But that's the first thing, is to look at the expected value. And then secondly, how likely would it be to get 4 out of 10 average BSU freshmen agreeing? And so here, we would have to compute a binomial probability in the way that we've been talking about today. And I want to deliberately rush through this computation to give you and your groups a chance to begin to sink your teeth into it. But we would say, what's the probability that x is equal to 4 in my group? Well, for my example, what are n, p, and x? Let's start with n. If I have a group of 10 people, and each one has a 32.3% chance of agreeing, and I want 4 successes, then what's n? Yeah, n is the total number of trials that we have, the number of people that I have to worry about, the number of people that could either be yes or no. And p?
4.
So p here is the probability of success. Probability of success in each trial. So that's usually not going to be a whole number. Usually that's going to be some percentage, some number between 0 and 1, because it's a probability. But what role does 4 actually play here?
4 divided by 10. I don't know.
Yeah, I want 4 successes in 10 trials. So 4 here is my number of successes that I'm looking for. Number of successes. So that's my x. Number of successes desired. And what is the probability of each success? If success means agreeing with this statement, 32.3%. So here n is 10, p is 0.323, x is equal to 4. And then I would have to multiply together the binomial coefficient, 10 choose 4, multiplied by the probability of success, 0.323. And if I need 4 successes, I'll raise that to the 4th power. And then I also have to multiply that by the probability of failure. How would I find the probability of failure here? 1 minus p, 0.677. And how many failures do I need if I have 4 successes in 10 trials? 6. Exactly. A quick check is that those two numbers on the top, those two exponents, have to add together to give me n, the number of trials. So here 4 plus 6 has to be 10. So we know we have the right combination. So that's what I would then have to compute. So we need to compute the probability that knowing that each BSU freshman supports abolishing the death penalty with a probability of 32.3%, that's p, we want to know the probability that a randomly selected group of 10 BSU freshmen, out of that group 4 of them support the abolishing the death penalty. So the binomial probability formula has us multiplying 10 choose 4, the binomial coefficient arranging 4 yeses among 10 votes, times the probability of success to the 4th power, that corresponds to the probabilistic contribution of 4 agreeing with this statement, times the probabilistic contribution of the other 6 disagreeing with this statement, that's q, the failure probability, raised to the power 10 minus 4. So first, for 10 choose 4, for this binomial coefficient, we'll set up a big fraction with 10 on the top and 4 on the bottom. We'll form the decreasing product in the denominator, multiplying 4 by 3 by 2 by 1 until we get down to the 1. And that tells us that in the numerator we need to do the same thing, stopping after 4 factors. So 10 times 9 times 8 times 7. We should have the same number of factors multiplied on the top as we do on the bottom. Now, simplifying this ratio, we can just do by reducing the fraction or just by computing the numerator and denominator and dividing. Let's reduce the fraction. We can cancel the 8 factor on the top with the 4 and the 2 on the bottom. We can reduce the 9 on top with the 3 on the bottom to get a 3 on top. And what we have left is 10 times 3 times 7 all over 1. That's 210. So that's the value of this binomial coefficient that's out in the front. Then we need to multiply that by p to the 4th. P is our success probability, the probability of one randomly selected freshman agreeing with this statement. That's 0.323, raised to the power 4 because we need 4 to agree with it. But then we need the other 6 to disagree. So we need to multiply the disagreement, the failure probability, 0.676, to the power equal to the number of students in this group who need to disagree. That's 6. So in total we'll have 210 times 0.323 to the 4th times 0.676 to the power 6. Pulling out a calculator and multiplying these together, I get 0.2181, or about 21.81%. So given that 32.3% of all BSU freshmen agree with the statement the death penalty should be abolished, if I get 10 randomly selected BSU freshmen into a room, the probability that 4 out of those 10 will agree with this statement is the probability associated with the binomial random variable where n, the number of trials, is equal to 10, p, the probability of success on each trial, is 0.323, and x, the number of successes we're looking for, is 4. We can compute that by multiplying the binomial coefficient 10 choose 4 by the success probability p, 0.323, raised to the 4th, by the failure probability q, 0.676, raised to the 6th. That process gives me a probability of 21.81%, which is actually fairly likely because this agreement number, this 4, is actually pretty close to the expected number who we would expect to agree in a group of 10, which is 3.23. So we're kind of asking for a probability that is fairly likely to happen compared to others. For example, it would be pretty unlikely that 0 out of 10 would agree. It'd be pretty unlikely that 10 out of 10 agree. But it's pretty likely, relatively speaking, that 4 out of 10 agree, because 4 is pretty close to the expected number that would agree in any randomly selected group of 10, which is equal to n times p, the number in the group multiplied by the success probability for each one, which was 3.23.